welcome back to our second lesson in Chapter 4. This is Chapter 4.1b. We are going to do factoring, and we are going to find the greatest common factor and the least common multiple, the GCF and the LCM. If you haven't noticed, in this chapter, they go through in one lesson what we used to do in 7th grade in maybe 2 lessons, okay? So they go a little faster. They figure you should remember some of this with a little prompting. The first thing we're going to talk about today is prime factorization. Prime factorization means that we can actually express any composite number as the product of prime numbers. One of the ways to do that is to write a factor tree, or to draw a factor tree. And I've given you an example of one here in A. 12 is a composite number, and it is found by taking 3 times 4. I always have to ask myself with every line that I write, my first line is 3 times 4. Is 3 prime? Yes. Is 4 prime? No. So that means I am not done. I have to keep going. I was always taught to bring the 3 along with me, so that's why I bring the 3 down. But then I also have to factor 4 as 2 times 2. Now I check again. 3 is prime, 2 is prime, 2 is prime. So I have the prime factorization. This bottom line of the factor tree is very important. That's the bottom line. That bottom line there is what I'm also going to use when I do GCF and LCM. Now, I can write the prime factorization using exponents. There's 2 ways to write that prime factorization. Without the exponents, in which case it would be 2 times 2 times 3, or with the exponents, which means it's going to be 2 squared times 3. The exponent telling us how many times that number appears in that bottom line of the factor tree. Only I do not use exponents of 3, or of 1, excuse me. That's why the exponent on 3 isn't written. It would normally be a 1, and I don't write that, okay? Now, here's the deal. We usually write those factors in ascending order, meaning we start with the smallest number, which in this case is 2, and then we go upwards. Since this is so much of a review, I would like for you to hit pause, and then I will go over B and C. So hit pause, you do B and C, and then I'll show you how they're done. There's a couple ways to do 16. I have found that your shortest trees are if you can find the biggest factors that first go into the number. So I'm choosing 4 times 4. You will get the very same bottom line if you do 2 times 8, by the way. It's just you'll have to do an extra line. 4 is not prime. And again, watch out too, don't forget your multiplication signs. Those are very important. You have to tell me what you're doing. Now the prime factorization for this is going to be 2 to the 4th power. How'd you do on that one? 57. Oh, remember back to lesson 4.1a? This is one of the numbers that a lot of people like to tell me is a prime number, but it's not. 3 goes into 57. 3 times 19. There's nothing more to factor. 3 is prime, 19 is prime. So here, my prime factorization is just to copy down the last bottom line of the factor tree. How'd you do? Hope you got them right. Now, greatest common factor, least common multiple. These will have a lot of implication when it comes to fractions and rational numbers. What we do is state each number's prime factorization without exponents. And I really spelled exponents wrong there, sorry. But it's kind of like, what would that bottom line of the factor tree look like? Okay. Then I look for common factors between the 2 numbers. If I can find a number in the a factor in the one number that's also in the second number, then I have what's called a, meaning 1, common factor. Now the GCF is going to be the product of all the common factors. But what's the LCM? The least common multiple is going to be the product of the GCF and all of the remaining factors. I like to say that it's the GCF times the leftovers. So let's look at example A. The bottom line of the factor tree for 10 is going to be 2 times 5. The bottom line of the factor tree for 15 is going to be 3 times 5. I look for a common factor. Right here, the 5 is used in each number. That means it is 1 common factor, and it's the only one. So my GCF is going to be 5. The least common multiple says I take the GCF times all the remaining factors. Now here's where you can use your commutative rule, your associative rule, etc. To me, I think about it as, look, 3 times 2 is 6, 6 times 5 is 30. Other students say, okay, but 5 times 2 is 10, and 10 times 3 is 30. That's fine. So you can reassociate, you can commute whichever way you'd like. Hit pause, and you do B. In fact, if you want to hit pause and do B, C, and D, go right ahead. But for sure, do B. All right, let's see how you did. 20. If you have to do a little factor tree, go ahead and do it. But the bottom line of the factor tree is going to be 2 times 2 times 5. And I found over the years that if you can do the ascending order, it's much faster to do these. 16. Well, that's 2 to the 4th power, which means it's 2 times 2 times 2 times 2. That's 1 common factor of 2, and here is another common factor of 2. I take those two 2's and multiply them. My greatest common factor is 4. My LCM is going to take all the leftovers, the 2 times 2 times 5, and then times by 4. I look and I see 2 times 5 is 10, times 2 is 20, times 4 gives me an LCM of 80. So I look at it and say, all right, I have 5 times 2, then times 2, then times my GCF of 4. Let's move on to our next example. 21 is 3 times 7. 8 is 2 times 2 times 2. Now, if you will notice, there are no common factors. If there are no common factors, we say that the numbers are relatively prime. They're prime in relationship to one another. Because 1 is a factor of every single number, my GCF here has to be 1. Well, where does that come from? It comes from the old days when we would list all the factors of 21. We would list all the factors of 8. There's that 1. Only we do it mentally. Now, notice that since there are no common factors, my LCM is the product of the two numbers. So if the numbers are relatively prime, the fastest way to find your LCM is to simply multiply 21 times 8. 8 times 1 is 8. 8 times 2 is 16. So my LCM is 1/68. Hit pause and you do example D. 25 is 5 times 5. 4 is 2 times 2. There are no common factors. GCF is 1. If they're relatively prime, I multiply 25 times 4. My LCM is 100. And that is the end of lesson 4.1b.